Hi all, welcome to Kotha channel. In this video, I am going to show you how to create a recommendation based machine learning model. Okay, here I am taking an example of movie recommendation machine learning model. If you are streaming any movie or any web series in any OTT platform, it will show you a category that you may like this web series or documentaries or maybe the movies which you may be interested. So based upon the movie which you are currently watching it, they may suggest few other products. So similarly, when you're purchasing something in the or when you're searching for something in the Amazon or some other websites, even e-commerce websites, they will show you that you may be interested in this so on so products. So based upon the product or the item that you have selected in that so on so platform, it will suggest the related, the which are near similar products items that they will show in a recommendation box. Here I'm going to show you how a movie suggestion. So if you select one movie, so how it will select the movies which are similar to that movie. Okay, if I am watching a thriller, it has to suggest thriller based movies or web shows or documentaries which are available in that particular OTT platform. Okay, let's get into that. Building a machine learning model. So this is the, as I explained in the previous video as well, it is a basic structure. Okay, how to create a machine learning model. First we need the data set and we have to cleanse it and we have to split the data set into two parts: training data set and test data set. And 80% of our data set should be trained data and 20% of data set should be test data. Then we have to create a model which is most relevant to that whatever the recommendation model that we are building. Okay, and then we have to, once our model is ready, we have to train that 80% of the training data set to that model. So once our model is ready, then we have to test it with the 20% of the remaining data set. So once our model is ready, then we will be predicting that model. So here, instead of predicting, it will give you the recommendations based upon the real-time input data set. Okay, and then it will give you the movies or web shows that you may be interested. What are the tools, that prerequisites that we require to create this movie recommendation machine learning model? First one is pandas. Pandas is a basic Python library which will be used to handle the data sets. And scikit-learn is a Python library which will be having a huge number of algorithms. We have to pick out of which one, we have to pick one out of those huge collection library, then we have to work with that. And third one is pickle here. So pickle will be used to, once our model is created, then we have to export that our model and then we have to import our model into the application wherever you want to use it. So to deploy our machine learning model, we'll be using a pickle Python library which is also free to use. And another final one is streamlit. Streamlit is a Python library which will be used to deploy our machine learning models or to build a websites as a web application. In Python we will use the streamlit. So all these four Python libraries are we are going to use to create a movie recommendation algorithm. Now let's create the model. Command.exe. Import pandas as pd. So this is a basic one, I'm just importing it. Next, read our file. Data is equals to pd dot, it's a csv file, right? Csv. Let's copy the path of the file here. Netflix titles, copy as path. Invalid argument. Okay, now ready with our data ready. Let's check how our data looks like. Data dot head. Okay, so now we have 1 2 3 4 5 6 7 8 9 10 11 12 total 12 columns are there. Okay, first one says show id, which is unique for each and every show or movie. and type says that whether it is a movie or a TV show, and third one is a title, so name of the movie show or TV, sorry, title decide, sorry, third one is title, which is title of the movie or TV show. Next director, next cast, and next is country, and when it was added to the Netflix, and when it has been released, and what is the rating and duration of the show, and it is listed whether it is a documentaries, and similarly documents or reality TV, romantic TV shows, it is like a genre, and the description of the movie. Okay, now let's understand what is the input parameters and output parameters. Okay, so input parameters, show ID will not create a much impact, but we would need the show ID to identify that whether it is to identify the data. Okay, so we would need it in the input parameter set, and type whether it is a movie or TV show. Okay, let's have that one as well. We need the title to display, yes, and director, yeah, few people may be interested to watch the Christopher Nolan movies, few people might be interested to watch the James Cameron movies, so let's have the director as well. And next one is cast, yes, cast also plays an important role. Okay, country, I don't think it would make much impact, so let's ignore that. And another one is date added, that is also not make any sense. And release year, that is also does not make any sense. Rating and duration also we can ignore, so we can have only listed in description and cast, director, title, and type, and show ID. So let's take them now. Okay, data is equals to, and before going over there, so we need the director, cast, and listed in description. These four columns are the input columns that would decide whether that, based upon these four columns, maybe we can suggest one is the, maybe few people might be interested to watch that particular video for particular director movies or TV shows. Some may be interested in casting, and some may be interested in the genre, some may be interested in the description as well. Suppose the TV shows, let's take an example of TV show, reality TV, few the description might be looks like similar. Maybe if you take the genre of the thriller, so the description might come under similar to that, right? Might exactly the same, but it comes similar, so that will also play an important role. So what I would do is I will add all this director, cast, and listed in description into a new column which is called tags. Okay, let's add it over here because these things are going to play an important role. Data of director, then I'm just adding this all these columns separated by a space. Okay, and date of cast, okay, and date of what else listed in, so it will give us the genre. Next, oh, I have to add space over here. Next space, date of description. Okay, shift enter. So have created new column called tags by combining director, cast, listed in, and description, which are separated by comma. Now let's see how the data looks like. Okay, now we have 13 columns. So earlier we had only 12 columns, now we had 13 columns. Okay, now what I would do is let's drop these columns: director, cast, country, date added, release year. We don't need all those things, right? So what we can do is data is equals to data of show ID, show ID, and title. We need type as well, right? Type and title, and then tags, which is recently created by us. Anything else? Show id, type, title, tags. Okay, I think that's good. Okay, now let's print the data. Yeah, now we have same 8807 rows with the 4 columns, and by seeing itself I could see there are null values in the tags which would affect our model performance. So let's remove those rows. Okay, data dot drop na would delete the data of the null rows. Okay, in place is equals to true. Okay, it has given a warning, that's fine. Let's check our data. It is having 5700 rows now. Earlier it is having 8807. If you see here, our index says it is having 8806, but we have only 5700 rows. If you see here is the index is not in a sequence, so we have to reset the index. Okay, data dot reset index in place is equals to true, and drop is equals to 2. What exactly drop works is, so here if you see here 2 and 5, so it is having only 5700 rows, but it is having the index till 8806. So somewhere in between, if you see here 2 and 5, 3, 4 are there, so we can delete those entries over here, and then it will reset the complete index. Okay, shift enter. Yes, that's done. Now let's run the data. See, now the index has been changed to 5699. Okay, so now we have the data after removing the null values, and we have removed the unnecessary columns, and we have reset the index as well. Now we have the 5700 rows with the 4 columns. Now we are good with the data. Now we have 5700 rows. Now import from sklearn dot, let's see the possible options here is feature extraction dot text import count vectorizer. Okay, the count vectorizer converts the alphabetic values to the decimal value or numerical value, which will be later feed it to the algorithm. Okay, now let's create cv is equals to count vectorizer with the max and score features is equals to 5700 rows which we have, and stop words is equals to English. So it will create the shape of 5700 rows. For each and every row it will create a vector, and with the stop words is equals to English. So repeated words we are ignoring them. Okay, and I am pressing enter. Okay, count vectorizer. Now it's gone. Okay, so once counter vectorizer ready, then we have to call our algorithm. The algorithm which we are using here is cosine similarity. From sklearn dot, we can press tab in the Jupyter Lab, it will give you the suggestions. Okay, models, sorry, metrics dot pairwise import cosine similarity. Let's understand how cosine similarity works. Cosine similarity measures the similarity between two vectors by calculating the cosine of the angle between two vectors. It is by the definition. Okay, in reality let's understand how exactly it works. I took two examples, two documents as an examples. First one is hi world and second one is hello world. So to find out the difference between these two, okay, how similar these two sentences are. First, the cosine similarity will draw these two vectors in XYZ dimensional graph, hi world and hello world. If you see that hi world will be drawn between X and Y axis, for example, okay, and hello world has been drawn between Z axis and Y axis, okay. And to find out the how similar these two sentences, we have to identify the theta. So the theta dictates that the value of theta defines the how similarity between those two sentences, hi world versus hello world. Suppose if I have 100 records, it will draw the 100 vectors in the XYZ dimensional. And then if I have to find out the similarity between first record versus the 50th record, then it will find out the difference between the angle of difference between the first record versus 50th record. That will give us the how similarity between the record 1 versus the record 50. So this is how cosine similarity works in reality. Now we understand how cosine similarity works. Similarity is equals to cosine similarity of, let's pause this vector. Okay, it's giving an error. Let's check it out. Invalid parameter it is giving. Okay, I got the error here. I have to add one more step here. So we have to convert our input data set to vector, right? So vector is equals to cv dot transform of data of, which is tags. We are preparing the tags, right? So that is the only input column. Based upon this tags, we have to identify the title. Okay, so we are converting cv dot transform dot values as type. We have to choose the UTF-8 code page here, then to array. Okay, we have created a vector with the only the tags column, and we are converting them into UTF-8 and to array. Press enter. That is done. Now vocabulary not provided. Let me do one thing. Let me execute it from the starting again. Okay, here let me use fit underscore transform. Yeah, it worked. Now we are passing it to the similarity. Instead of CV, here I have to pass vector. It takes some time. Now print the similarity to see the data. So here it has been created an array for every, this is a one row and this is the second row and this is the third row. Okay, so it will create a similarity for the total 5700 rows are there, right? So first take an example of first ganglions. The first row will be compared and identified the similarity from 0 to 5000 remaining 5699. For remaining all those entries, it would calculate the cosine similarity. How similarity it is, this ganglions is to the remaining 5699 rows in the data set. Okay, so that is the similarity here. Now let's find out the similarity for a particular movie. Okay, now let's take an example of index data of title equals to let's take one movie title here. Yeah, let me take this one, Zodiac. I'm just pasting it here. I'm just taking the index of this particular movie. Okay, data of title Zodiac. Okay, dot index of 0. So 5696. So now we got this 5696, right? Let's identify the similarity of for this 5696. Similarity 5696. Yeah. So this is an array which would be containing 5699 entries, which is from the starting of 5692 versus remaining all the records which are there in the input data set. Now let me convert it to list and enumerate. A list, enumerate this one. Then let me sort it out in the reverse basis, because we need the data which is nearest to that or which is similar to whatever our input data set. Okay, comma reverse is equals to true. So we are sorting the similarity for this 5696 in descending order to identify the most recent or which are near to for whatever the title that which you have selected. Okay, then we have to key is equals to lambda, then vector is equals to vector of 1. Okay, so this is a, so if you see here 569 it calculated for itself as well, which is 1.004, which is 100%. So this particular movie is 100% similar to the same movie. Okay, that is what it is giving. So next similarity movie is 3636 with an index of 26.37 and 4320 also 26.37. So something 1905 is 24.49%. So this is how it is have been calculated for entire thing. Okay, so what I can do is we'll assign this to a variable, okay, instead of entire thing. Okay, let's call as distance or movies. Okay, similar movies. Okay, now we have similar movies. Let's print only top, we need only top 6 movies. Okay, similar movies for I in similar underscore movies 0 to 6. Print data of dot allocation of I of, okay, 0. Okay, dot title. Okay, if you see here I am just taking the top 6. Okay, the first one, why I took top 6 is the first one is Zodiac, which is similar to the same movie name, so we have to exclude that movie name. So we'll take the remaining 5 recommended movies. So for the Zodiac, these remaining 5 are the recent ones. These are the similar ones based upon the data of the tags. Tags is nothing but the based upon the director, cast and genre and the description of the movie. Okay, I want to see the percentage of nearest similarity as well. Okay, in the recommendation, how nearest it is. Okay, the percentage of the nearest. Print I of 1, I guess, right? Let's see that. Yeah, so Zodiac with 100% and 2-1 from New York with the 26.37. Same Gothica, what did Jack do? Same interrogation and Highway Man. Okay, so this is how we can find out the most based upon the cosine similarity. We can identify the what are the nearest values for this particular movie or the product. Okay, so let's understand this code once again. So here in the starting we have the data pandas spd. We are reading the input data set which is containing the list of the movies and TV shows and documents are there in the Netflix OTT platform. And here it is a tags. I've created a new column called tags by concatenating the director, cast, listed in description. These are the input columns which we thought would make an impact when suggesting a movie. Okay, and we have finally removed the unnecessary columns. We took only the show ID, type, title and tags, only these 4 columns, into the data set, and then we have removed, if there are any null values, we have removed that. Yes, the our initial data set was around 8800 records. It has been reduced to 5700 rows after removing the duplicates and null values. Okay, and here we have the reset index. So we have reset the index after removing the null value records. Then our data set reduced to 5700, and then we have reset the index from 0 to 5699. Okay, so once our data set cleanup is done, then we have taken the count vectorizer, which will be used to convert the text data into the numerical data before passing it to the uh, our algorithm cosine similarity. Okay, here as our data set is 5700, we have created a vector shape with the vector with the shape of 5700 versus 5700. So that's the reason I have mentioned the maximum features as 5700 here, and we are eliminating the words which are in English, which are common usable, which would not give much context when we are suggesting something. Okay, in from the algorithm perspective. Now we take in the algorithm which is cosine similarity. So cosine similarity is an algorithm which would calculate the distance between, it will draw the dimensions in xyz for all the vectors which are there. So suppose here we have 5700, right? So it will draw the dimensions in 5700 records, and it will find the difference between the similarity to find out the record 1 versus the record 2 by the that angle between the cos theta, the angle between those two vectors, the theta will, so it would give us the value of the similarity between those two rows. Okay, and here it is, we are converting, so we are creating a vector for our tags. Okay, and with the UTF-8 Unicode value, and we are passing that into the cosine similarity. So the similarity matrix will create for 5700 rows, 500 700 records for the each and every row for itself as well. For the self record also it will create the uh, cosine similarity. So here I have taken a zodiac index, I am taking it, it is a 5696, and I am passing it to the similarity array, and then we are sorting it on the reverse basis, and then we are getting the first row. Okay, we want only the title, right? Vector versus vector 1, so we want the title which we wanted to print, so that is what here. And here it will give us the 5700 entries, so we wanted only the 5 recommended movies, right? So that is the reason I am just taking the similar movies of 0 versus 6. So it will come as the top 6 movies which are similar to the zodiac or TV show. Okay, so here it is a self one. We don't want this one, right? So let's change here it to 1. Okay, and let me press shift press enter. Okay, so now the self record is gone. So to one from New York is the most recent one. Okay, most similar one for the zodiac, and next one is Kotika, and third one is what did Jack do, and fourth one is interrogation, and fifth one is the highwayman. Okay, so this is the complete part. So let's build a function with all this logic. Okay, definition of recommend movie name, okay, as an input parameter. Okay, let's take the data here instead of this one. Okay, movie index is equals to this one. Instead of zodiac, here what we are going to pass is movie name. Okay, so once we get the id, so we'll be passing it to this one, similar movies thing. Okay, so once it is done, so we are printing these things. Okay, let me change a little bit here. Print with similarity of okay, remove this one. Okay, invalid syntax error. It is a text similarity of Okay, now recommend movie of, take the first one, any movie name from here. Let's take this one, TV show, Gonglands. Pass it here. K can only enter, can only concatenate string. Okay, here I think it is giving an error. String, okay. String of, yeah, so here it is. It is giving the top 1 2 3 4 5, so top 5 recommendations. If you observe here, it is not working as expected here because I'm passing this index here is by default 5696, which is for the our previous movie title Zodiac. So let me change it to here. Let's make it as a dynamic one. Now shift plus enter. Now again here as well, re-execute it. Now here it is. So Bangkok breaking with similarity of 51.21%. It is giving this floating numbers. Let me convert into the integers. Mm, round off, multiply it with 100 and round it to 2. Okay. Mm, okay. Yeah, here it is. Now Bangkok with similarity of 51.21, dealer with similarity with a 50.83% similarity, the forest of love deep cut, okay, and sleepless society and unlucky ploy with the similarity of 47.36 for the gong lines. So here it is, the final code. So now we are done with the code with the recommendations. Now let's take it to the another level. Okay, we will build a web application. Okay, once I select the movie name from the list of the movie names, it has to give us the this list of these recommended movie names. Okay, so for that one we will need to, for these model names, right, whatever the model that we have created, okay, we would need this similarity model, right? So we would need this similarity model. So let's export this similarity model with the help of a custom Python library, which is pickle. So with the use of the pickle, let's export the similarity and the data set as well. Okay, let's import pickle. Yes, pickle will work like it, right? Once again, k. Okay, now pk dot dump, it will dump. So what exactly dumps is into a model. I would need the data. Okay, here it is, the data, comma, open movie data set dot pkl, that is the extension of a model. Next with the wb, w in the sense with the write access. Okay, so where it exactly it creates this, where exactly it creates this pickle file is in the folder, root folder of here is python movie recommendation. Okay, let's enter it. Incomplete input, yeah, typo, enter it. Let's check. Yeah, if you see here, it has created a model, it has exported this movie data set into a pickle file. Okay, now we have to export one more thing, pk dot dump of similarity. We can export the similarity matrix. Okay, open and similarity dot pkl with wb. Okay, we have exported similarity matrix as well, similarity model as well. Now let's import these two models into an application. Let's take it into the another level. So now we have two pickle files, one is movie dataset pickle file and another one is similarity pickle file. So with the help of these two pickle files, we'll create a web application. The first thing is we'll create a drop down with the list of the titles. If I select one movie, it has to show me the recommended movies names in the bottom. Okay, now for this one I'm going to the Visual Studio. Okay, and here we have this movie dataset and similarity. Okay, and let me create one file. app.py. Okay, let's build the app first, and first I will import pickle as pk. Okay, now let's take that pk dot load. So we have to read those thing data, right? The first one is movie data set pickle. Okay, I can't be able to open it, sorry, my bad. Okay, route movie data set dot pickle, and let me assign it to a variable movie data set picky dot load with the open of. Okay, we need only the read thing, right? So rp here, so we don't need write access. Let me open it and run python file in a dedicated terminal line. Okay, it completed successfully. Now we have imported movie dataset. In the same way, import the similarity as well. Similarity is equals to pk dot load of open of similarity dot pkl comma with read access. Okay, now let's run it again. Yes, it completed successfully. Now I have these two data sets. One is movie data set, we have loaded this model, and with the similarity as well. Now let's create a make use of the streamlit. So streamlit import streamlit as st. So what exactly streamlit does is it will give the perfect platform to create the web applications in python, right? Now run this one first. So I'm coming to terminal here. Streamlit, let me save this one first. Streamlit, sorry, streamlit run app.py. Okay, if I run it, it will open in a new browser. Okay, and let me go back to the code. Let's first set some title. Okay, st dot header movie recommendation. Okay, save it, and I'm going back here. Yes, source file has been changed. Yes, please do rerun. Okay, here I have to change the settings. Go to settings. If I enable run answer, every time I make the changes in the source file, and if I save it, it automatically reruns it. Okay, going back to yes here. Now we have the models of the dataset and similarity. Now let's build the drop down. Okay, st dot select box with movie dataset of title. Okay, here we have to give the header select movie or TV show. Okay, now check in the browser how it looks. Yeah, if you see here, select movie or TV show, so it has listed down all the movies and TV shows which are there in the data set. Now we have our data set is ready. Drop down is ready. Let me change it to camel cases escapes. Okay, now it's done. So we have to read this value, right? Okay, selected movie, I just take it as a selected movie. Okay, and let's create a button. Okay, if st dot button equals to button of recommend. Let me save it. Going here, and here if I change anything, okay, I can click on this button. Okay, and once the button is pressed, if recommend pause, saving it, and I'm pressing it. Okay, it's working fine. Okay, now we have developed a function for this one, right? Once we pass the movie name, so it automatically gives us the recommendations. Coming here and Jupyter Lab. Okay, copying this entire function from here, going to Visual Studio. Okay, I have pasted it. Okay, I have made some mistake. I should not be doing it here. Let me paste it here. Okay, little bit above, and I have to minimize this terminal. We don't need it now as we are checking everything in web application browser. Okay, here it is a movie name. Here the dataset name has been changed to movie dataset. Just changing the names here and there. Okay, that is done. And similarity is same, so no need to change anything. And yes, we're good, right? So instead of here, let's create a, we have to return this one, right? We cannot be able to print here. Okay, recommendations, it's an array. Okay, recommendations dot append. Okay, now we have done with this one. Now so once the user presses the recommend button, now we have to here return first these things, return this recommendations. Oh sorry, this recommendations first. Okay, now our function is ready to use. Let's call our function here. Final result is equals to recommend movie. For which movie? User selected movie. Okay, we have passed it here, so we are good here. So now we have to print, we have to create a variable, right? We have 5 movies here, so we have to repeat that for each and every time. Okay, column 1, column 2, or else let's do one thing. Okay, now let's print these ones. Okay, st dot text of result of 0. Let's check whether it is working fine or not for 1. Okay, click on recommend. Yeah, so it is recommending. Okay, now we have to repeat the same thing for the others as well. Okay, home, total we have 5, right? So result set of 1, result set of 2, result set of 3, result set of 4. Now saving it, click on recommend. Yes, so it is recommending the same thing, go Garrison, Halloween, go Garrison, Christmas. Okay, underdogs with a similarity of 27, which is very least, and this highest one is 61.13, and here it is 55.36, 50.82, 47.99. Okay, let me choose again the zodiac which we tested earlier, right? Selecting it, clicking on it here, recommend. Yeah, so same results it is showing with the similarity of 26.38, 26.38, same Gothica with, and what did Jack do with 24.49, interrogation and highwayman. Okay, now let's choose anything, any other one. Yeah, choose Ganglands, same of Bangkok banking with similarity of 51.21, dealer with similarity of 50.83, the forest love. Okay, fine. So it will work for all the movies whenever we select any Jaws. So it will recommend Jaws 2 and the Jaws. Okay, Indiana Jones and Indiana Jones Adrift with similarity. So it will recommend the similar names. So if you see here, if I select Jaws and then 2, it is recommending the first one as a Jaws 2 because that is the most relevant one for the Jaws, right? And even the Jaws the Revenge as well. So this is how, so we can conclude that even in practically that our movie recommendation algorithm is, movie recommendation machine learning model is working as expected. So this is how the movie recommendation machine learning model is working. So it's, I would say that it is working as accurately as it is we have coded. I think that's, we can have in real time, maybe we have to just check the data and then we have to cleanse the data a little bit more, but more or less it comes similar to like this only. If you find this video is very useful, please do like it and subscribe to our channel. Thank you for watching this video. Have a good day. Bye.